Okay, Jack, could you tell me what is your data all about?
So our data is all about the trying to see if the observed value and the expected value are if they have a significant difference.
Mm-hmm.
And so we're using the chi-square,
Yes.
which is this is your your sum overall, I guess. And
This
then
chi-squared equation,
is your chi-square equation,
which is actually there. Look at that. There's some
Yes.
missing in there at the bottom.
right here.
Okay.
And then, and what we're trying to prove is whether or not our 50-50 gold and silver.
What is that 50 and 50? Could you tell me that?
So 50 and 50 means 25, there's 50 total in this population right here.
Okay.
And 25 of them, 50% is gold,
Yes.
and 50% is silver.
Okay.
And
So that's
on and
recessive.
so forth with all of
All
these.
right. So how did you do that? Like, how about that one?
With
The
how did
observed
we solve
value. No, the observed value.
the observed value?
Yes.
Random selection.
Random selection.
We just went in there.
So you have those 50 number of silver, 50 the other one. So it's more like probability, right?
Yes.
Okay. How did you solve the expected value?
We solved the expected value by Hardy-Weinberg.
Hardy-Weinberg equation, which is?
Yes. It is p squared
Yep.
plus 2pq plus q squared equals 1.
Okay. So what is that in there? Looks like HO.
HO. Right here is
Yes.
the null hypothesis.
What does that mean?
It means if these have no significant difference.
Okay.
So it's just trying to, it's saying that with random selection and with our tabulated value, they equal the same.
Okay. So what is that in there? So how do you solve for that one?
How do I solve for these?
Yes.
And so with these examples right here,
Okay.
how we solve is we take our O and E, our observation value and our expected value.
Okay.
So for example, with number 1,
Yep.
we use 7, which is our, we use p squared, we solve for p squared, 2pq, and q squared.
Okay.
Our 7 comes from this right here, our p
Okay.
squared.
Great. So
And
how?
then we have our p squared right here.
So how would you decide whether you're going to accept or reject your data?
We decide by whether or not our number is bigger or smaller than this number right here,
Okay.
our
Okay.
tabulated value.
All right. So when do we reject and when do we accept?
We accept when it is less than for right here.
Okay.
3.26 is less than 5.99.
Right.
We reject when 7.52 is bigger than 5.99.
Okay. All right. So that is chi-squared, right?
Yes,
All
sir.
of it? And therefore, your conclusion would be for each of the data is based on there. So what do we use next in the future?
What we use next is called the zero test or zero score.
Oh no, the z-test?
Z
You mean
test.
the z-test, yeah.
The z-test or zero score? No?
Yeah, and the other one is the standard deviation, right?
Yes.
Okay. That's all, Jack. Thank you so much.
No problem.